Welcome back to the Historic Mathematics Academy, an inclusive organization founded on truth, where curiosity and engagement connect philosophically to encourage lifelong learning. As always, we're glad you're here, and we hope you'll enjoy your lessons with our wisest teachers, Socrates, Plato and Aristotle.
Hello again, I'm Aristotle. Last time we were together we learned about quadratic equations, which when graphed, are parabolic curves. Quadratic relations relate the variables x and y, where a variable such as x is raised to the power of 2. And remember, quad in the term quadratic refers to a square. I'd like to help you to better understand quadratics by literally thinking of a square. Here, you can see that both the length and width of this square are represented by the variable x. Now, let's calculate the area of this square, which will be represented by the variable y. Do you notice something familiar about this equation? Yes, you're right. This is actually a quadratic relation, shown in factored form. And now, when you multiply both variables together you have the classic quadratic equation y equals x squared, which is the same quadratic relation but now in standard form. Take a moment to consider the units of the length variable x compared to the area variable y. If x is in meters, then y would be in meters squared. Let's visualize another square. One that is larger by the unit 1 in both dimensions, in length and width. Each dimension has the length x plus 1. Now, let us calculate the area of this square, using the variable y again. Notice when you multiply the length and width, it again creates another quadratic equation in factored form. Let's continue to multiply the parentheses together and expand the right side of this equation. Notice how the blue x plus 1 parentheses is multiplied by each term x, and 1. We then continue to expand our expression, and you can see here that there are now two like terms, both with the variable x. Once we add these like terms together, we have changed this quadratic relation into standard form. I hope you've enjoyed this lesson to help you understand how quadratics relate to squares. Now, I would like for you to learn from my teacher, Plato.
It's good to see you again. My name is Plato. I would like to help you to interpret parabolic curves on a graph together, which as you know are quadratic relations. Consider this graph of a rocket launched from the ground. The y-axis represents height in meters, and the x-axis represents time in seconds. As you can see, the top point of the curve has the coordinates 5 and 500. Last we were together we learned that this point on the graph is the vertex of the quadratic. Now, let me ask you some questions about this particular graph. What is the initial height of the rocket? Next, how many seconds is the rocket in the air? Next, what is the maximum height of the rocket? Next, at what time does the maximum height occur? Next, at what times is the rocket 320 meters above the ground? Lastly, when does the rocket hit the ground? Well done. I can see that your hard work is paying off. Keep it up. Now, I'd like for you to continue learning about quadratics with my teacher Socrates.
Hello again, my friend. My name is Socrates. I'd like to help you master changing quadratics from factored form to standard form, and from standard form to factored form. Let's begin with this quadratic equation, which is in factored form. Remember that in this form, you can easily find the x-intercepts by setting y equal to 0. But, what if you're interested in knowing the y-intercept, which can be found from standard form? All you would need to do is multiply the parentheses together. Notice the x term and the positive 2, seen here in green. Each of them are multiplied by x minus 1. Once that is complete, we can see that there are two like terms highlighted in blue. We then add these terms together, and we are now in standard form. Here you can see that the C coefficient is -2. This, as you know, is the y-intercept. So, moving from factored form to standard form can be achieved simply by expanding through multiplication and addition. I wanted to show you this first, because it will remind you of the process to change from standard to factored form, which is the product sum rule, seen here. As you recall, there are two equations to this rule. One, which finds two numbers that adds to the coefficient b, which is +1, seen here in blue, and another that looks to find the same two numbers found in the first equation that also multiply to the coefficient c, which is -2, seen here in red. The two numbers that satisfy both of these two equations are +2 and -1. Can you see the connection to why +2 is green and why -1 is black? That's right, they are the very same two numbers that are in the parentheses of the original factored form. Once you have these two numbers, you can change your quadratic equation from standard form to factored form. This is factoring. I've enjoyed my time with you. Now, I would like for you to practice what you have learned with my greatest student, Plato.
Hello again. Let's apply what you've learned from Socrates by solving some quadratic problems together. Have a look at this problem. Solve this quadratic by finding its x-intercept by first changing it to factored form. Now that you are familiar with the product sum rule, can you think of two numbers that both add to +2 and multiply to +1? Good work, both of these numbers are +1. Now, we insert these numbers into our factored form format seen here. And remember, factored form reveals the x-intercepts by setting y equal to 0. Can you solve for x? That's right, there is only one x-intercept here. -1. Let's try another problem. Have a look at this problem. Once again, solve this quadratic by finding the x-intercept by first changing it into factored form. Can you think of two numbers that both add to +5 and multiply to -6? Great work, +6 and -1 are correct. Now, we insert these numbers into our factored form format seen here, and find the x-intercepts by setting y equal to 0. Can you finish this problem and solve for x? That's right, -6 and +1 are correct. I had a great time practicing these math skills with you, and I hope to see you back here soon.
We hope you enjoyed your stay at our Historic Mathematics Academy. Thank you for your curiosity and for engaging with our math teachers. We appreciate your time. Please remember to stay safe, to get your rest and to continue your lifelong learning. Bye for now.